Transmitter board. On front panel of this card, following are provided: frequency window, code bit window, LED indications, L9, L1, L2, L3, L8. Note: no measuring sockets are provided on this card. Transmitter board consists frequency plug, coding plug, quartz oscillator, modulator. The transmitter card consists of a quartz oscillator with modulator. Here, the audio frequency voltages from 4.75 kHz to 16.5 kHz are generated and modulated with the bit pattern. Frequency plug selected determines the track circuit frequency required. In FTG S46, in FTG S917, another coding plug determines the bit pattern to be transmitted. Different bit pattern code plug numbers are as per this table. For these plugs, pins are provided on top side of card near front side. Track frequency generated is modulated by frequency shift keying, but according to bit pattern. LED L2, L3 indicates the shift keyed frequency according to its frequency position. LED L2 lights up for the upper frequency and LED L3 lights up for lower frequency. Resulted time division multiplex signals are feed to amplifier and filter circuit. LED L1 indicates voltage output of amplifier. An additional circuit is provided, that is generation of scanning pulse to evaluate receiver and demodulator signals. The clock frequency of 16,336 Hz is generated by dividing the frequency of the quartz oscillator. LED L8 green light indicates correct functioning of additional circuit. LED L9 green light indicates correct functioning of intercode short circuit supervision. The bit pattern is voltage dependent. If operating voltage falls below preset limit, the bit pattern is inverted. This is recognized by the demodulator, which then de-energizes the track relay via receiver to board. After recovery of voltage, a defined operating sequence in receiver 2 prevents the emission of track occupied signal as long as there is no fault in the installation. Filter and amplifier board for FTG S917. The filter and amplifier board raises the modulated audio frequency of the transmitter to the required level and then transmits these raised signals via selective filter to the feed-in tuning unit. Because of the selective filter, each frequency has its own specific card. This amplifier is push-pull switching amplifier with transformer decoupling. Its output is in square wave, which is feed to transmission filter. Filter's output is in sinusoidal wave, which is feed to TX tuning unit. At filter's output, all higher harmonics are suppressed to avoid interfering of other transmission system in and beside the track. Fluctuations in the operating frequency due to faulty signal generation and processing lower the level at the filter output. Amplifier board for FTG S46 only. This board is suitable for the complete range of frequencies of the FTG S46. Output of transmitter board can be measured on amplifier board as input to amplifier circuit. Measuring socket is provided on this board with LED indication L4.1. Filter board for FTG S46 only. Each frequency requires a special filter card. This filter board must be matched with length of the feed in cable by means of a jumper which is inserted in accordance with the cable compensating resistance. The jumpers are specified in this table. Measuring socket for filter output with LED indication L4 are provided. Receiver 1 board. On the base of multi-stage input filter, there is a specific receiver 1 board for each frequency. The receiver 1 board evaluates the amplitude of the track voltage. When the track is clear, the board passes pulses to the demodulator board and electrically isolated DC voltage to the receiver 2 board. Input filter. The received voltage from track is fed to band pass filter. This band pass filter possesses a broad flat transmission characteristic with steep edges. Transformer coupling at the inputs and outputs of the filter matches voltage and resistance. Input amplifier. For fail-safety purpose, the input amplifier is dual channel design. The two channels are identical in design. The low input voltage is stepped up for the amplitude evaluation. The amplitude of the stepped up input voltage is evaluated by comparing it to a fixed threshold value. If the threshold is exceeded by half wave, one pulse is generated. Gain adjustment. Gain adjustment for received voltage can be done on receiver board after removing from the evaluator. Before removing the board, switch off power supply of evaluator. One dip switch block is provided for this adjustment. When switch is on downside, it is open. Gain adjustment shall be done as per table given. Dip switch position 1 and 10 or 1 and 9 or 1 and 8 or 1 and 7 or 1 and 6 have highest gain. Dip switch position 2 and 10 or 3 and 10 or 2 and 9 or 3 and 9 or 2 and 8 or 3 and 8 or 2 and 7 or 3 and 7 or 2 and 6 have normal gain. Dip switch position 3 and 6 have lowest gain. After commissioning, no adjustment should be done except during monsoon season when the ballast resistance is affected. After adjustment of gain, TSR testing is compulsory. Measuring sockets with LED indications are provided on front panel of this board. Input from site RX tuning unit can be measured in socket E1 and 2. One L5 LED indication for channel number 1, 2 L5 LED indication for channel number 2. Demodulator board. This board consists arrangement to accommodate coding plugs, quartz oscillators, comparator circuits, 2 outputs to receiver 2 board. This board has 2 channels. Both channels are identical in their dynamic behavior but with an exactly opposite structure. The 2 channels differ in following aspects. The logical signals are inverse. The counters run counter to each other. The PROMs are inversely programmed. The input signal is conditioned and triggered in reverse directions. The flip-flops are logically inverse in their operation. By this arrangement, 2 out of 2 logic is achieved. The function of the demodulator is to evaluate the bit pattern of the voltage received. The demodulator is activated by receiver 1 after the evaluation of the amplitude of the track voltage. The 2 serial bit sequences, external from site and internal from code bit plugs, are compared by an EX or exclusive OR gate. If they are the same, the comparator goes high. If they are different, it goes low. This result of comparator is indicated by LED 6. Front panel of this board consists of 2 windows for code bit plugs for each channel. LED indications. One L6 lit proves code bits received are correct for channel 1. 2L6 lit proves code bits received are correct for channel 2. No measuring socket is provided on this board. Receiver 2 board. Two types of boards are available as below. S25533 B39A3 for standard track circuit. S25533 B34A3 for point track circuit, for center fed track circuit, for crossing track circuit. Receiver 2 board. Basically, this board is divided into three different stages: clock pulse amplifier and operation output stage. This board consists two identical channels for safety reasons. Final output track relay is driven by each channel. Clock pulse amplifier. For each channel, the AND operation requires a scanning pulse. This is generated on the transmitter board. The clock pulse amplifier amplifies and shapes this signal and converts it from the 5 volt to 12 volt DC. Dynamic and operation for each channel. The receiver 2 board combines the output signals of the receiver 1 board, amplitude evaluation and frequency, and demodulator board bit pattern check. And also chronological sequence of the two signals is checked when the track circuit is occupied and when it becomes output stage. This stage is for each channel. This stage consists pulse expander, amplifier, transformer, rectifier. Output voltage is supplied to the tracked relay in relay. This output is indicated by LED 7. Front panel of this board consists of two measuring sockets for each channel with LED indication. In measuring socket 111 and 112, output of output stage to track relay 1. This output is indicated by LED 1. In measuring socket number 211 and 212, output of output stage to track relay 2. This output is indicated by LED 2L. Relay board. S25533 B36 A3. This board consists of two tracked relays, one for each channel. These relays are Siemens K50B type relay with contact configuration 4F/2B. These relays are named as GF1 and GF2. Front contacts of both GF1 and GF2 are wired in series. Back contacts of both GF1 and GF2 are also wired in series. These relays are interface between FTGS and signaling interlocking. These relays are made slow to pick up by 600 milliseconds and also are made slow to drop by 250 milliseconds.